Hello everyone, this is Jonathan Sherwood, and today I want to showcase off a basic SpriteMover game that I was working on. I think it was good in order to be able to refresh some of my creative juices while working on my previous game for so long, so I thought it would be a good opportunity to also learn some ways to do clean coding, work on some of my own sprites. So everything you see here I made myself, and I also wanted to just have a quick game to crank out just for some fun. So you make it through the maze, and you win. Let's look into how I did everything. One of the first things that every game needs is a sprite, or something that the player can use to be able to see what they're interacting with. Just because there are game objects here in the hierarchy doesn't mean that they actually display on the screen for the player to understand. That's why we need a sprite renderer over here. The sprite renderer has a lot of different functionality that you can input into it, such as what the sprite actually is, like my slime, if it's flipped, either on the x-axis or the y-axis, or a few other functionality like that. The next thing you'll need is a script attached to your sprite in order to get it to move around. You can see an example of how you would do something like that through this code. While this is a little rudimentary, it's a basic idea of how to be able to move the transform of the object based on a key press. So, if the input of GetKey is the up arrow, but not also the down arrow at the same time, that's when you would move the transform. You would move it up, which is just shorthand for 0, 1, 0, or 1 in the y-axis and 0 in both the x and the z, times a modifier of that you can set within the inspector. We'll talk about that in a minute. You'll also want to do it based on delta time so that it's not running based off of your computer speed, but actually just based on time. But what if you didn't want to move the sprite based on where it currently is, but instead to a very specific location? Instead, you could have him teleport back to the origin. And how would you do that? Well, rather than increasing the position by a continuous vector, you would instead just tell it what the vector is. You say new vector 3 and then tell it where you want it to go, in this case 0, 0, 0 for the origin. This happens when you press space. Now that we've gotten the basic of movements down, what if you were a designer who didn't know much about programming? You wouldn't want to have to go all the way back into that code every little time you wanted to adjust something, and what if we wanted the speed to be faster or slower? Many times a programmer will make a public variable that shows up in the editor. Rather than a consistent number, this variable shows up in many different locations. Every single one of these will change at the same time whenever it's changed in the editor. So, if you felt like the speed really wasn't working for you, rather than having to stick with 3, you could press 5. That will change it to 5 throughout the code because of that variable. Now let's see what it looks like. The player moves a bit faster now. If we were to change it again, it's even faster. This is a very quick and very handy way of being able to alter your code inside the editor, looking at it real time. That works well if you want to be able to change the movement speed of the player in the editor. However, what if you want the player to move differently while they're playing? For this example, I've had it that when you hold shift, the player will just jitter 1 meter in each direction. And this is easily shown by the code here. Once we're inside our if statement pressing the up arrow, it starts to do the rest of the function here. However, the first if statement within this one is immediately skipped if we're not pressing left shift. That's why we've been moving the way we have been so far. However, what if the player was holding left shift? No longer will it be willing to move to the second statement, and instead it needs to fill out the rest of these requirements. In this scenario, we do GetKeyDown instead of GetKey. This means only one time that it's pressed will it activate. And once you do, it will only move it up, which, as we said, was 0, 1, 0. This means it'll only move 1 meter up. There is no multiplication and there is no variable adding to it, which means you will always only move up once, and only once because of GetKeyDown. Likewise, what if you wanted to stop the player from being able to move at all? Say they hit a trap or they were deactivated somehow. Well, in order to do that, for example, I've made it that when you press P, no matter what you press, the player is unable to move. Press P again, and you regain control. Because the script we've been in up till now is called SpriteMover, it was important to make a game manager instead. Moving down to the project files, you can see that the assets are all individually packed into different folders for organization's sake. The game manager script is here. In this script, we have it affecting the player in a multitude of different ways that are not necessarily related to movement. For example, we have a public variable, the SpriteMover. Calling it SpriteMover means that whatever you assign to this has to have the SpriteMover script attached to it, otherwise you can't assign it as the designer. For now, we'll call this the component to be disabled. While the game manager is never present in the game, it still needs to exist in the hierarchy for the script in order to work. Because we set the component to disable as a public variable, you can easily click and drag the player who has the SpriteMover script into this variable. That means that you'll be directly interacting only with the player, even if the script exists multiple times. Coming back into the script, we can see in the if statement input.GetKeyDown keycode P that it's calling the variable we just created, component to disable. The bool enabled is being told that whenever you press P, do the opposite of what it currently is. You'll be starting it as enabled, however when you press P, the opposite of that will make it disabled. Pressing it again, it will do the opposite of what it has become, which is disabled, turning back into enabled. You can also see that we've done GetKeyDown because you don't want the player to accidentally hold P and then not know whether it was pressed or whether it wasn't. The game manager would also be in charge of functions such as dying or losing. So, for example, when I press Q, the player character disappears. While it is just deactivating at the moment, you could have a slew of other functions that turn it into the lose condition and not just removing the player. However, press Q again, and the player has returned, which you could use to reset the game. This is shown by another variable we created that you can choose in the editor, Object.To-Deactivate. This is called, in the same style of code, input.GetKeyDown Q. Once again, it calls the system we already have, Object.To-Deactivate, and then instead it's a function setActive. Now normally you could do something like true or false. However, much like we did previously, you can just do the opposite of what it currently already is. If it's active in the hierarchy, then it's set to not active in the hierarchy. If it's not active in the hierarchy, it will do the opposite, once again turning it back on. Lastly, the game manager could be in charge of the entire game session itself. So, if input.GetKeyDown escape, this function actually works completely on its own. No extra coding is required. Application.Quit. That will stop the application from running and shut you out of the window. So, once you finally finish the game and you're ready to turn it off, all you have to do is press escape and it will close the game for you. You win, escape, and you're out of the game. That's everything you need to know for now about how I created SpriteMover. Thanks for watching.